Okay, we're gonna quickly go over the mean API starter kit, right? All of these things are links, and later on when I send you this PDF, you'll have access to these links, right? So we're gonna talk about the mean starter kit. We're gonna add some test data in there, just kind of walk you guys through that, and then we're gonna do something very simple with NS predicates. We're gonna basically take the to-do list app that we built yesterday, and we're gonna add a predicate to only return us the unchecked entries in our to-do list, right? Which makes sense. And then at the very end, we're going to talk about Grand Central Dispatch, and then I'm going to show you guys a little video. We're going to watch 10 minutes of it, of the Apple guy describing it, because that's the authority on this. All right, so let's see if we can get this done before 11. All right, so we have the iOS API starter kit here that you guys can get if you go to this link on my GitHub. It's all there, right? So I'm just gonna edit the one that I was building with yesterday. So we're gonna open it in Atom, and then I'm gonna run it.
How did you do that? Open that folder in the terminal.
Atom space curate opens everything. Oh no, he has a shortcut for it.
Oh, okay.
Yeah. So if you have like these so you mean how I open this folder? So yeah, I set it using, so basically you go to System Preferences, Keyboard, Shortcuts, Services, and then down here you'll see that you have a new terminal in folder, and I just set my hotkey to be Control Option Command equals, and wherever I do that, I can open a folder.
You just highlight the folder
in the terminal. Yeah, you highlight it and then you press the hotkey and it opens up. All right, so. Cool. So we have it running. It's on port 8000 right now. So if we go to 8000 and we go to the tasks, we should see this message, right? And this message is there because in the code here, I'm just going to quickly walk you guys through each of these files, the ones that are useful at least. All right, this is the server.js. I have some very nice little ASCII documentation here. Over here, we're requiring some stuff. We're setting up the express and body parser, right? So this line you must have, and I didn't have this like yesterday, and then Kyle showed me that we need to have it. So this is the one that will give you access to the API request, post data from the Swift, all right? And then here we're requiring this database file, and we're also requiring the routes file. And over here we're listening on port 8000, right? So in the server file, we have a config folder, and this mongoose.js lives in that config folder. So this is mongoose.js, right? We're requiring mongoose, we're requiring file system, and then we're connecting to the database, and I named it iOS bucket lists. You guys can name it anything you want. It's going to be a local database on your computer, and this basically is a little algorithm that helps you get all of the files in the models folder. So no matter how many model files I have, I don't have to require them individually. This will loop through that folder and just require all of them, right? In the routes.js, we're requiring the controller, which is going to be in the controllers folder, tasks.js, right? So in the routes, I'm requiring that, and then I'm making this route with a get request for tasks, and it's going to call the index method on my tasks controller. So this guy, index method, right? So that's why when I went to /tasks, it logged out this message. Now you do it, right? And this is a res.json, and it'll return that JSON object whenever you call it.
Are you using Express?
Yes, we're using Express. So these are the folders that you're gonna, generally be touching. The last one is gonna be the models file, right? We're making a tasked model, right? The only thing we have in there is an objective. It's gonna be a string, and then we have this timestamp true. So every time we create a new, entry into that model, it's gonna just give us the timestamp data automatically, right? So I wanted to show you guys how we're gonna, have a way to have some dummy data to kind of test. So when you guys connect this and you run this on your local computer, in your iOS code, you're going to want to, get some tasks back. But right now, there's nothing in the database, right? And it's really difficult for you to add stuff from iOS to this, without setting up a bunch of things, which the platform will go over later on. So I wanted to show you guys how to kind of build some dummy data so that when you cook it up, you can see that it's working on your app, right? So you get some JSON data back. So the way we're going to do that, really easily, we can make a new route. Let's make a new route, and we're just going to say this is add data, or add dummy data, like that. Okay, and then we're going to say tasks. We're going to run the method called add, and then we're going to go to our tasks controller, and we're just going to add that method that we wrote, right? So it's going to be a function. It's going to have a request and a response. Over here, whenever we call this function, I wanted to add one entry into my tasks database, right? So in mean, this is like a refresher. You got var new task equals to task, and I have this variable available to me because I required that model. And in here, we're going to put in the object with objective. The objective is going to be, my first task, like that. Okay. Once we have this guy made, we're going to do new task dot save, which will save it to your database. It's going to take in a callback function with the error argument, and then we're going to pretend there's no errors right now, and we're going to say res.redirect, and you're going to redirect me to tasks. Okay, so we'll see it as soon as we hit the add. Okay, and in the tasks, this will redirect me back to this route, which we'll call the index method. The index method, right now it's just res.json that, but what I want to do is I want to get all the tasks from the database. So task.find everything dot execute with the callback function with the error and the result. And then, if there's errors, we want to log the errors, but right now let's just do res.json the result that we get. Alright, so if we do that, when we first load this again, oh, look at that, I have some stuff already. Well, let's delete that stuff. So I'm going to open Mongo Chef, and this is an external program that I really like to use with my mean stack MongoDB stuff, because it's kind of like a visual interface for visualizing your data, your databases. So instead of using the terminal and typing all of those commands to edit my database, I can just do it here using MongoDB or using a Mongo Chef. So I got, what is this called? iOS bucket list, right? So we got our tasks, and we double click on it, we see all of these tasks, and I will just highlight these, and I'm going to delete them. So now there's no more tasks, right? So if I refresh this, I got nothing, right? It's an empty array. But if I go to add dummy data, boom, I got one, and it says objective, my first task, right? So I added that. So now if we do this, we change this here, my second task, and then I go back to add dummy data, boom, now we have a second one, my second task. And then, doing this, and this is just like a temporary thing, right? My third task, and then we'll go back to add dummy data, boom, we have 3 tasks, right? So now it's saved in your database. If I refresh Mongo Chef, I see that I have these 3 entries in my third task, right? So now that you have that and you hook it up, you're going to be able to see some data come up when you make the request to your API, right? Without you having to set up all the things to kind of add through the iOS app. Right, so I just wanted to kind of show you guys that. You have access to this Mean API Starter Kit on the GitHub. All right, let's get into NS predicates. All right, so NS predicates, they're really, really easy to use. there's a lot of different ways you can use it, not just with core data. You can literally do an NS predicate to sort through an array or something, like anything that has data, right? So there is this website here that I use to learn NS predicates, and there's a lot of different resources out there to kind of show you how to use predicates. And this one even talks about compound predicates so that you can have multiple like different filtering selections, right? So you have access to this guy, is NS Hipster. This website is pretty cute. And then we got, I'm gonna show you guys how to do NS predicates in the context of this to-do list demo. Okay, so yesterday we had this to-do list demo. If you click on the link here, it'll bring you to that video. All right, I'm not gonna play the video. So over here we have this to-do list demo, right? This is the one that we were working on yesterday. So I'm just gonna open up this guy in Xcode. I'm gonna run it and let's see what we got. All right, and there should be some data in here because yesterday we added some data. Cool. So we have 1, 2, 3, 4, 5, 6 entries. 3 of them are checked, 3 of them are unchecked. We can check and uncheck any one of these that we want. But right now, let's say I want to check this one, and the last one, these 3. Right. So if I close it and I run it again, those changes should be persisting because I'm saving everything in core data. Yeah. Right. So let's say we wanted to have like a button up here that was like, hey, if I click this button, I want to toggle all of the list items, or if I toggle it, it'll only show me the ones that are not completed, right? So that would make sense in terms of this app. I don't want to see every single thing. I only want to see the things that are not completed yet to make use of the app, right? So let's see if we can do that. Let's see if we can add a bar button item here somewhere. All right, so I'm going to stop this guy. We're going to add a bar button item.
Are you still going to call all of the items, or is that and filter them after, or are you going to?
No, I'm making an NS predicate to only search for the things that have that are not done. Right, so I'm not finding everything and then filtering it. Although I could do that, but using NS predicates, you can just integrate it with core data, and it's really easy to do. And I'll show you guys how to do that. All right, so bar button item up here. Hey, we can just put it here, right? We can say this is, let's say, organize, or maybe not organize. Let's say we'll just do. Let's just make it compose. Okay, whatever. We'll just have it as this icon. It doesn't matter, right? But it's. I was looking for the filter thing.
Go find a sprite, download it, and import it.
Okay, so we have this button here. Now let's go ahead and make the action in our code. So we're gonna say this guy. You are going to have an IB action, handle, toggle, button pressed. The sender is a UI bar button item. Okay, so we got this guy here. Every time I click on this icon, it's going to run this function here, right? So over here, let's say that. Let's not worry about toggling this button for now. We'll go back to this later. But the thing that we want to do now is get all of the results with, that are unchecked, right? So in order to do that, in the get all data function, right? And this function is where we're querying core data. We're fetching data from core data, right? So after I establish my my variable here, my constant called item request, and this is an NS fetch request fetching from tasks entity, right? We're getting, all of it, but we're defining this query, this fetch request in this line, and we're actually executing that request in this line, right? So in between the fetch request and the execution of the fetch request, we're going to add our predicates. Add our predicate. Okay. So how do we do that? Let's take a look. And honestly, I haven't really memorized the syntax, but it's really easy to do. Right. So over here we have, let's say that we have a. All right, which one is it? There was a really good one that I looked at. So this one is pretty good. This one's pretty good, yeah. So we're gonna create a constant. We're gonna say let filter unchecked predicate, and we're making this very explicit, right? So that is just the name of our constant, and you are an NS predicate with this format. Okay, and the format is going to be, let's see how they did it. All right, so we have, it's basically just the, there's many different ways you can format, you can write out the format, but this is, I think, is the easiest one, right? So they have the NS predicate format, and they have whatever the column was, and then whatever the comparison is, right? So in this case, we're just going to copy that here. We're going to get rid of this guy because we don't need it. And in this case, in our model, we have this attribute called checked, and it's a Boolean, true or false, right? So over here, we can say the attribute we're looking for, is checked, and I want it to be equals false, right? Because we only want to find the entries where checked is false, right? So that's, we're defining this predicate. And in order to integrate our predicate into our fetch request, it's literally as simple as this. Item request, right? This is the item request, and it's a dot predicate equals to this predicate that we just made. Right? So if I have this and I run it again, I should be only seeing the 3 entries that were unchecked. Right? So let's run it. Or the 4 entries that were unchecked, right? So none of the checked ones showed up. So if I wanted to toggle between this back and forth, like the only difference, the only thing that I added was this, right? So all I need to do is just write a variable to check the condition to say, are you the status of want to see all of it, or do you want to see only the ones that are unchecked, right? So up here, let's go ahead and make a variable called see all, right? And this guy is going to be Boolean, optional, right? In the view.did_load, I'm going to set this see all to be equals to true because we want to see all, right? And then down here, we can say if, if not see all, then we want to go ahead and implement this predicate stuff. Or else, we just want to do what we were doing before. Okay. So now if I run it, I should see everything. Yeah, see, I see everything here. Let's check this guy. And now, let's say the last part we're going to add is the toggle button. When I click on the toggle button, if see all is true, then I want to set see all to be false, right? Or else I want to set see all to be true. So I'm just toggling it between true and false. And the thing I need to implement after this is done is to do the get all data request again, because otherwise I won't see the change, right? So if we run this, it should be working, right? When we click on the toggle button, it should just toggle between all of the data or some of the data, right? There we go.
Nice.
Right. All right. So that is NS predicates. You can learn more about it by reading the NS hipster stuff. Also, there's a ton of stuff on Stack Overflow that show you how to do with Swift 3. Just know that this is there, and you can very easily implement it. Right? Okay, so the last thing today I want to show you guys, I want to briefly talk about Grand Central Dispatch. I'm going to show you this video, and we're going to summarize it at the end of the video. Right? So, in a general sense, like you guys know, there's a CPU in your computer, right, that handles single-threaded processing very quickly, like a machine gun firing like 1,000,000 rounds per second, right? But every round is sequential. I cannot execute the next one until the one before it is done. And then you have your GPUs, which are like you can think of them as many like little weak CPUs that execute everything concurrently, but cannot handle like super crazy complex sequential operations, right? So it's like an array of handguns that can only fire very slowly, compared to like one machine gun that can fire very fast, right? So why am I talking about this, right? So on your iPhone today, we have our very powerful CPUs, but nowadays they're like quad core or like double core, something like that. So the CPU, one CPU core can only handle one thing at a time. Although it's very powerful and very fast, still it can only handle one thing at a time. Now, if I had a very powerful CPU with one core, it's always going to be either on or off, right? So what that means for me is that I'm going to get a ton of processing power or no processing power, meaning that if my phone is on and I'm using it, it's going to drain my battery, right? So that's why Apple has made these like different cores so that when you're like on standby, it's only using like one of the weaker cores. And then if you're processing images, it's going to open up the different other cores that consume more energy, but will give you that power, right? And what is it that handles that kind of which core do I turn on? How do I allocate the different processes? It's Grand Central Dispatch, right? So Grand Central Dispatch is the one that integrates with the hardware of your computer. And it's like very sophisticated technology there that integrates with the kernel on your phone that has the authority to turn on and shut off cores and allocate different like processes, right? So we call this threads, right? Grand Central Dispatch can manage your different threads, right? So think of them as like how many cores or how are you going to use those? And today you can have multiple threads on a single core, but they happen in a way that's like intercrossing. Right? But I mean, that's kind of out of the scope of what we're talking about. But the thing that we need to know is that, Grand Central Dispatch will utilize different, cores on our phones to do different tasks and make it very efficient and energy, efficient, right? Another thing I want to talk about is how iOS handles concurrency, right? So when the app is running, there's always one main queue. You can think of this as like the event loop on JavaScript, what things get done, right? And that main queue is always going to be allocated for UI-related things. So by default, everything UI goes on the main queue, which is the priority queue. It's prioritized over all the other queues. So as long as something is on the main queue, nothing else will get done, right? But the main queue needs to always listen for UI, touch gestures, so that to the user it feels very seamless, right? If you're doing other things like image processing or HTTP requests, Grand Central Dispatch will automatically move that to what's called a dispatch queue, and you can have many dispatch queues, and you can either manually create a dispatch queue, like we did with the Core Motion starter kit. We made a queue, right, and we put everything on that queue. Then when it's done, we merged it back into the main queue to have it update, right? So, but the idea here is that there's different queues. The main one is for UI. If something is on another queue, we're going to have to force it back into the main queue for it to update quickly. If we don't do that, it's going to update whenever nothing's on the main queue, which can be X amount of time in the future. Right? That's why sometimes it's like doesn't refresh until you kind of scroll around, right? So with that said, let me show you this video from Worldwide Developer Conference, straight from the horse's mouth. We're gonna watch 10 minutes of this, just the beginning, so you get an idea. Can you close the door?
There's no choice. Yeah, that's fine.
I'll try to block it.
Yeah, I'm gonna have to go down when I say up.
Good afternoon. So, I'm going to talk to you this afternoon about how to structure your programs with concurrent programming and what we've done this year that's new in GCD and Swift 3. My name is Matt. I'm going to be joined later by Pierre. And we're both on the Darwin runtime team here at Apple. So when you create a new project, you're going to have something that looks a little bit like this. You have your application, and that application gets its main thread. That main thread is responsible for running all of the code that powers your user interface. As you start to add code to your application, you're going to find that the performance of your application changes quite drastically. For instance, if you start to introduce large items of work, say data transforms, or image processing on your main thread, you're going to find that your user interface suffers drastically. On macOS, this can be the spinny wheel appearing. On iOS, it could be something more subtle. Your user interface will slow down or maybe even stop entirely. So I'm going to take you through some basics on how to structure your application to avoid this kind of problem. And later on in the talk, Pierre is going to come and take you through some more advanced topics. So how do we deal with this kind of problem? We have to start by introducing the idea of concurrency to your application. Concurrency allows multiple parts of your application to run at the same time. On our system, you achieve concurrency by creating threads. A CPU core can execute one of your threads at any given time, but the payoff for introducing concurrency, the penalty for introducing concurrency to your application, is it's much more difficult to maintain your thread safety. The other threads that you've introduced can observe the effects of you breaking your code invariants while you're performing operations on other threads. This becomes a bit of a problem. So how can we help? Well, GCD is the concurrency library on our platform. It helps you write code, multi-threaded code, that works on everything from an Apple Watch through all of our iOS devices, Apple TVs, and all the way up to a Mac. So in order to help you with your concurrency, we introduced some abstractions on top of threads themselves. That is dispatch queues and runners. A dispatch queue is a construct that allows you to submit items of work to that queue. In Swift, this is closures. And dispatch will bring up a thread and service that work for you. And when dispatch is finished running all of the work on that thread, it can tear that worker thread down for you itself. As I said before, you can also create your own threads, and on those threads you might run loops. And then finally, on the first slide we saw, you get your main thread. And the main thread is special. It gets both a main run loop and a main queue. So dispatch queues have two main ways that you can submit work to them. The first of which is asynchronous execution. This is where you can queue up multiple items of work to your dispatch queue, and then dispatch again will bring up a thread to execute that work. Dispatch will one by one take items off that queue and execute them. And then when it's finished with all the items on the queue, the system will reclaim the thread that it brought up for you. The second mode of execution is synchronous execution. This is where, for instance, if we have the same setup as we had before, the dispatch queue with some asynchronous work, but you have your own thread, and that thread wants to run code on that queue and wait for it to happen, you can submit that work to the dispatch queue, and then that thread will block. It will wait there until the item that you've asked to execute is completed. We might add some more asynchronous work to that queue, and then dispatch will bring up a thread in order to service the items on the queue. Again, the asynchronous items will be executed there. And then when it comes time to run the synchronous item that you've asked to run, the dispatch queue will pass control over to the thread that was waiting, execute that item, and then control of the dispatch queue will return back to a worker thread controlled by dispatch. It will continue to drain the rest of the items on that queue, and then also reclaim the thread that it was using. So now I've shown you how you actually submit work to dispatch. How do we use that to help us solve the problem we had earlier? Well, what we want to do is get the work off your main thread that's causing you to block your user interface. And we do that by taking the transform that we had on that main thread and running it on a different queue. So you can take the transform and you can back it with a dispatch queue. And now when you want to transform data, you can move the value of that data to your transform code on the other queue, transform it, and then send it back to your main thread. This allows you to perform that work while the main thread is idle and servicing events. So what does that look like in real code? Well, it's really simple. So first of all, you can create the dispatch queue to submit your work to by just creating a dispatch queue object. It takes a label, and that label is visible in debugger as you're writing your application. Dispatch queues execute the work that you give them in, first first out order. That is, the order that they were submitted to the queue is the order that dispatch will run them. And then you can use the async method on your dispatch queue to submit work to that queue. So now that we've actually submitted our resize operation here to a different queue, well, how do we get that back to the main thread? That's very simple too. The dispatch main queue services all of the items that you execute on it on the main thread itself. This means you can just call dispatch queue main and then call async on that main queue, and that code will execute and you can update your user interface from there. As you can see, it's very simple to chain work from one queue to another queue and back to your main queue again. So now we've seen how to get.
All right, so you get the idea, right? This video goes on for like 35 minutes, and towards the end of it, it gets really, really kind of heady. But just know that this actually does happen in the background, and as you get into more advanced iOS projects, you're going to have to kind of manipulate the different queues to make your app perform better, right? And also another thing to note in a context of this in this course is that when you make those HTTP requests, Grand Central Dispatch automatically moves that piece of work to a dispatch queue. That's why when we didn't use AlmoFire, we had to do this line, dispatch queue.main async, to move the results back into the main queue so that it updates our UI quickly, right? Because it's happening on a dispatch queue. And it's doing that without us even having to do anything because Grand Central Dispatch did it for us. Now, like he did, you can actually create your own custom queue to do like a bunch of heavy processing work. Once it's done, move it back, right? So we have the ability to kind of create many, many different queues. That's about it.
So you're saying when we're using AlmoFire, it's putting on another queue,
yeah,
and then but it didn't put it back.
AlmoFire does that for you.
We had it automatically puts it on another queue, but we have to manually bring it back to the main.
So every time you're making an HTTP request, it's automatically going to be put on a dispatch queue. AlmoFire just brings it back for you, right? So if you're not using AlmoFire, you got to do that yourself. But AlmoFire just kind of handles that behind the scenes to make it easier for us as developers. That's the power of the framework, right? But yeah, I mean, this stuff is pretty crazy. Apple spent a lot of resources kind of, developing this kind of technology so that people can build apps that work very well, and then the consumers will be happy and buy more phones, right? So
blows my mind to like people can even get on that level to make stuff like that, and I don't even understand it.
They're making some crazy stuff. All right, so that's it for the